Yeah, the greatest common factor. And what is that, GCF? Well, eventually it'll be 20, but we're pulling out a 4 to make it a 20.
What?
The common factor between these two numbers is, I was going to circle it, but it's going to make it a mess. So we have a 5 already. If we factor out a 4, that's going to remove a 4 from the inside, introduce it to the outside. We'll be looking at 4x squared plus 1. But then you can multiply those two outer things to give you a 20 multiplied by 4x squared plus 1. All right. So it's kind of fitting that the first problem involves the greatest common factor. It's the first type of factoring that we learned about. And also, it's the most commonly forgotten type of factoring. So when you lose credit, if you lose credit, hopefully it won't happen, but if you lose credit on a test related to factoring, so let's say you're strong in factoring, you worked hard, you studied, you came for extra help if you needed it, you took the test, you got like minus half a point here, minus a point there, you're like, oh, I got nickel and dimed all over the place, what happened? Odds are you forgot to pull out GCFs. Right? So it's something that you always have to be asking yourself, is there a GCF that I can pull out? If you ask yourself the question, that's half the battle right there. All right, so just constantly ask yourself the question, can I pull out a GCF? So in number 2, can I pull out a GCF? Yeah, sometimes the answer is no, all right? So it looks like a GCF was already pulled out. In the case of number 1, somebody tried pulling out a GCF, didn't come up, they came out with a common factor, that's where the 5 came from. They just didn't get the greatest common factor. It looks like they succeeded in number 2 in taking out the greatest common factor, but what do we have left over here? What's this guy? What type of factoring is that? Well, I have a subtraction in there. It's also known as it's another word for subtraction. Minus, another word?
Negative.
Negative, another word? If it's in a word problem,
Negatory.
negatory, totally. Negatory, bro. How about difference? Difference, subtraction mean the same thing, right? So, are there 2 things in here? Are they both perfect
Yes.
squares? Difference of 2 squares?
No.
Yeah. So this is a dot situation, difference of 2 squares. All right. You don't have to use the abbreviation if you don't want. You can write it out. Some people use DPS, difference of perfect squares, whatever you like, just as long as you identify. Because some questions will ask you to identify what type of factoring you need to use. All right. So, like, just visualize a test. Like, every time you take a test, you have the multiple choice section and then the free response. A multiple choice question could be something like, here is the factored form of a particular polynomial. What technique was used? Dots, GCF, dots and GCF. You know, it could be something along those lines. So we got to be careful, and we have to know what these things are called. All right. So what are the factors of 4x squared minus 9?
X squared, like -3.
Well, we're gonna have an x squared. We're gonna have a -3, but we're missing something. I'm sorry. We're gonna have an x and a -3.
Oh, yeah.
There's one little thing that's missing. A 2, yeah. Yeah, it should be 2x minus 3. And then what's the other factor?
2x minus.
2x plus 3. Yeah, so it's made up of the same stuff. It's just one has a minus sign and the other has a plus sign. Okay, it's a negative positive or positive negative. The way we get each of these guys is by taking the square root of the 2 terms that make up your difference of 2 squares. All right, so we take the square root of 4x squared, becomes 2x, goes in the first slot in each binomial. Take the square root of 9, becomes 3 and 3. Make one positive and one negative, and there you go. All right. All right, so in number 3, it looks like maybe somebody was doing some factoring. They got this far, but they didn't finish the job. They need to do one more thing. What's that thing? Well, they got a factor. Factor the first parentheses using what technique? Greatest common factor, yeah. And what would that greatest common factor be?
3.
3. All right, if I pull out a 3 from this guy, what do I have?
3D
Minus 2. I feel like maybe there should be an example 4 where the answer is, it's factored. It's already done.
Yeah.
Yeah, somebody can take that for typo.
Please.
Do you have to take a picture?
There's a GCF for this.
There is a GCF.
And this
GCF would be 12
B.
B. Yeah, there's a variable there, so you got to account for both things. All right, if you miss a factor when you're taking out a GCF early on, it's not the end of the world. You just take out a GCF. I mean, it wouldn't be technically a GCF. It would just be a common factor, but that's splitting hairs. Nobody's losing sleep over that. But if you forgot the B, in the next step, you'll be like, oh, there's a common B also, so let me take out a B too. You know? So let me pull out the 12B. When I do that, I'm essentially dividing each term by 12B. What am I left with?
B squared minus 4.
Indeed. So this is a two-stepper because this remaining binomial here is what?
Factorable.
It's factorable using what technique?
Dot.
GCF.
Dots.
We just use GCF.
Yeah, the only way we'd be using GCF again is if we forgot a factor in the first step. So it is possible that we'd use GCF twice, the technique twice, but if we did it right the first time, we shouldn't have to do it again, right? Unless it's factoring by grouping, which we'll get to in a few minutes. All right, so if the 12B stays put, what will be the factors of B squared minus 4?
B. Minus 2. Yeah, that's what I was thinking.
Exactamundo. All right, B minus 2, B plus 2. All right, so look for that GCF first because, you know, at first glance you see a difference in the original problem. Same thing with number 5. It's like, okay, maybe I have a difference of 2 squares. Like a difference of 2 things, all right, but are they squares? No, but maybe if I pull out a GCF, they will be. All right, so that's what you want to be on the lookout for. But let's hop over to number 6. And do some of the even problems. Okay, so in the case of factoring by grouping, what we want to do is apply the GCF technique twice to different parts of the polynomial. So generally what we try to do is partition it right down the middle and then go from there. So let me do that. I'm going to go meh, and then pull out a GCF for each piece. All right, what would my GCF be for the left-hand side?
4.
4.
Say A.
My bad.
It's just 4.
No, he's thinking ahead to the second part. All right, so pull out a 4 for the left-hand side. What am I left with?
A plus 3.
All right, now on the right-hand side, we know we're going to pull out an A. What else can I pull out?
B.
A B. What about signage?
No.
A negative, yeah.
Yeah.
All right, so if I divide each of these terms by negative AB, what am I going to be left with?
Three.
I think I heard it. Among all the wrong answers I heard, I think I heard the right
A
answer.
minus 3. A plus 3.
A plus 3. All right,
Go for the ball.
that's what we're hoping for, because factoring by grouping fails us if the binomials don't match up, because then we can't apply the next step. So if you pull out your GCFs in this step here, and these 2 binomials aren't the same, that means you organized it incorrectly to begin with, right? So that means that you got to erase all your work, rearrange the polynomial, group it up differently, and then try the process again. All right, so it's fortunate that it worked out that we're looking at an A plus 3 in both cases, otherwise back to the drawing board. All right, so now I have a common, my GCF would be A plus 3, because it's common to each part. I have one in this term, I guess you can call it, and one in that term. All right, so if I pull out the A plus 3, just withdraw it right from the entire expression, I'm going to be left with a 4 and a negative AB. And that would be your final answer. Now, you can see how that, I mean, I don't think you need me to tell you this, that's the trickiest type of problem, because if it goes wrong in the beginning, you'll be at it for a while. You know? But then also, just think about a situation where maybe you pull out your GCFs and the inner expression, instead of being A plus 3, maybe it's A squared minus 9. So after you factor it out, you can still factor further, right? So the factoring by grouping is like the mega problem, where, I mean, if I wanted to, and I don't, but if I wanted to, I could give you a test with just one problem on it, a factoring by grouping question, because like a crazy factoring by grouping question, because it would encompass all the skills for the entire unit. It would have GCFs involved. It would have a difference of 2 squares if I wanted it to, right? It was a factoring by grouping naturally. So just one question would have all the skills for the entire unit mixed into, you know, just that, like I said, that one question. All right, so that's twofold. One, like I said, I'm not going to do that. That would be terrible. I mean, it would be easy to grade, I guess. But, you know, that doesn't matter to me. I get your test back the next day anyway. So. Yeah, it's no big deal either way. On your end, though, for practice, so you're like, oh, what should I focus on? Focus on factoring by grouping, because if you can handle that, you can handle everything, right? I think that makes the most sense. But there was another one. I'm trying to remember which. Oh, yeah, I know where it is. I know where it is. So, number 8 is one of those factoring by grouping questions. You look at it. It's not a two-termed expression. If you're going down the flow chart, first thing you'd look for is a GCF. There is not a single common factor that applies to all terms. You could take out a 4 in almost all cases, but that negative 3 as a coefficient screws everything up. They don't all have X's in them, so there's no GCF. It's not a dot because there's more than 2 things. So let me group it. That looks terrible. That looks glorious now. All right, anyway, I'm going to pull out my common factor of x squared. And I'll have a 4x minus 3. All right. Now, it's a nifty trick when it comes to factoring by grouping. Once you figure out one part of it, you can use that to help you figure out the other. So let's say I had no idea what I was supposed to factor out on the right-hand side. And in all honesty, in most cases, people know, or at least have a sense of what they're supposed to factor out. If they're going to screw up something, it's probably going to have to do with the signage. Like they pull out a positive instead of a negative, or vice versa. So here, you might have that kind of confusion. You say, okay, I know I'm going to pull out a 4, but is it a 4 or a negative 4? And you don't want to waste the time. Right? So what I'm going to do is I'm going to use my answer for the left-hand side to help me with the right-hand side. Because in order for factoring by grouping to work, the binomials, or at least whatever is left over within the parentheses, they have to be the same. So whatever this is, it has to be duplicated over here. So what would have to be in front of that, negative 4, in order to get you that negative 16 and the positive 12? All right? So it's kind of like, you know, it's legal cheating. It's like I did the work here. I demonstrated my knowledge and my ability. The skill is represented. It's fine. I don't feel the need to do it again. Since I already know what the factor is, I'll use that again and just think to myself, all right, well, I have a 4x here. If it was originally a negative 16x, it must have been multiplied by negative 4. A negative 3 must have been multiplied by negative 4 to give me a 12, right? Because this is a great exemplar problem, because you look at this and some of you, if you tried this on your own, you would have pulled out a 4 instead of a negative 4. I might have done the same thing. And if that's the case, you now just learned a technique that'll help you avoid that kind of mistake. All right. So I have a common 4x minus 3. I can pull that out. And so it's really just extracting it or withdrawing it from the expression. So if I remove it, if I picked up the 4x minus 3 from this part and threw it away, picked up the 4x minus 3 from this part and threw it away, what's left? Exactly. All right, so then now this is the part where you start talking to yourself. Can I do more? The answer to that question is another question. Is there a GCF? No. Nothing here, nothing here. Generally, I mean, this is not guaranteed, but generally, if there's no GCF in the original expression, there's probably not going to be one later on down the line either. So it's generally how it works. I don't want to say that's always how it works, because I'll do another problem and immediately find a case where it fails. So, but look for the GCF. It never hurts, because maybe you just missed it before. All right, that happens to me all the time. Looking at that x squared minus 4, next down the list, I guess. If you created your own flowchart based on what the order in which we're learning things, we learned greatest common factor first. Then after that, we learned difference of two squares. So we evaluate. Is it a difference of two squares? Well, the thing in blue is not. It's a difference, yeah. There's two things, yeah, but the squares. 3 is not a square. X is not a square. Although you could actually do something involving radicals, you're not required to, so we ignore that one and focus on this guy, which is a difference of two squares.
Okay. Bless you. Bless you.
Bless.
I do say thank you.
No problem.
I think one blanket thank you is probably.
Zach's excited. He's going to drop 15 for that if he's school.
You already know.
Unless somebody sneezes, then we'll be too busy saying bless.
Bless you.
And waiting for the thank you. Yeah, that's the thing. Well, it'll be still. X minus 2 plus 2. Nope, that's supposed to be red. All right, so this is one of those situations. You get to this step here, you think you're done. You might even be a little proud of yourself, like, oh, that was a doozy. Factor by grouping, that's tough. You know, you get to this one, you box it. You even see this multiple choice question. You see this as one of the choices, because it will be. Which of the following is factored completely? You get to this, you're like, got it. Chalk you up for 2 points right there. And then right below it is this one. And that's it. And this one looks ridiculous when you compare it to something simple like this one. So you'll be like, well, that's not it, because that one looks horrible. So yeah, I'm pretty confident I got this one right. And that happens a couple of times. You walk out of the test thinking you got 100 and come back in the next day, find out that you did not. So yeah, it's weird, but you gotta do that talking to yourself. Try to do it in your own mind, but if it spills out into the open, it's not the end of the world. I had that student who was like dead awful at Ken puzzles, but then he started working on them and like really practicing them, and he tackled, I want to say it was like an 8x8 puzzle in the library, and he finally finished it, and he just lost track of where he was. And he, puts the last number in the last box, and he's like, yes! In a quiet library. And everybody turned and looked at him. And they're like, whoa, what just happened? They thought he got into college. It was that kind of reaction. He's like, oh, nothing. No, seriously, what happened? You seem really happy. He's like, I solved a 10-point puzzle. Like, really? Yeah, they get over it pretty quickly. So if somebody over here is saying, all right, is there a GCF here? I don't know. Is there? Well, let me take a look. It's going to sound a little weird, but you'll get it right. That's the important thing, I think. All right, so looking at number 9, I asked the question, is there a GCF? Well, yeah. Now, that's question number 1. Question 2 is, what is the GCF?
So you would do that last part for everything that you have to
Oh,
break
no,
up?
no.
What's that?
Lucas.
You do that last part for everything that you could break up,
Lucas, are you sure you're deadlifting 275, not 75?
So it's not 36.
12.
12 will go into both of those numbers, yeah.
I for some reason I was like 62, 36. It works, but it doesn't.
Wait, 12 would be going to
Oh, 12 goes into 60.
Yeah, 12
Yeah.
would go to 60.
Crikey. Okay, back to the drawing board. Well, 2 works, 4 works. Does 8? No.
I think it.
Are we out at 4?
9. Wait. Is it 9 going to 64? 8? No.
No. I think it's 4 then, right? Yeah.
4.
When in doubt,
God.
use the GCD function in your calculator. A little quick 36 comma 64 and see what comes up. It's not just a 4 though, right? There's a variable.
4Q, I think.
4Q, yeah. All right, so 9p squared minus 16q squared. Whew.
Yeah.
Yeah, so we're down one power. So then you get to this and say, I did it. I achieved
Square.
everything. But it is a difference of 2 squares, so more work. Check for a GCF again, just in case. Because once you factor out a common factor, let's say it wasn't the best one. Let's say 12 was a factor that worked. You pull out the 4, it might be easier to see that you could also pull out a 3 after the fact. Right? So you can never go wrong pulling out what you think a factor is. Let's say you had no idea, so you pulled out a 2. And then you saw after you did that, oh, they're both even. I could pull out another 2, and another 2, and another 2, and keep going until you run out of the ability to take 2s out. Move on to another number. Right? So it's never a waste of time, even if you pull out the wrong factor. Right? So we have 4q. So this is the dots. We're going to factor by taking the root of each of these 2. 3p, meow and meow. 4q, right meow, and also right meow. And then 1 minus and 1 plus. Doesn't matter which is which. And then again, just one last look. Is there a GCF? Is there anything more I can do?
Maybe.
No common variable. The numbers there's nothing common. If you're in doubt, GCD on your calculator. 3 comma 4. Math over the NUM column. And then I think it's 9.
Okay. What is that? It's boy.
Jackson's at home screaming right now.
Power interrupt. Seems like more set the clock.
Oh,
So,
Jackson's not here
do
today.
36 comma 64.
No.
Get the 4.
How do you get GCD again?
And let's say, I'm crossing the T's, dotting the I's, and I'm taking a test. I'm nervous. I'm losing track of things. And I look at the 3 and 4, and I'm like, you know what? I know there's no GCF, but just in case, let me let the calculator do the work. If it comes back to a 1, it means that the only number that could divide evenly into both of those numbers would be the number 1, which means that there is no common factor, no meaningful, non-trivial common factor. So, yeah, it's a good word. Yeah, I like it.
What does OLS stand for?
Our Lady of Sorrows. It's my son's school.
Those are pretty sad.
This is pretty much what I'm talking about. If you can handle this, you know.
This looks easy.
Yeah, it's mere child's play. All right. So we'll just kind of go after it the same way we did the last one. Then realize that that's probably not the best way to go, but we'll do it just to learn from the experience. All right. So if I partition it down the middle, and again, I'm just qualifying this by saying this is not going to work, but we'll do it because if you're given this problem, this is your first move. You try this, and if it doesn't work, you try something else. All right. So I look for a GCF, and actually maybe it'll work. I don't know. We'll see. Well, I know I can pull out an n squared. Definitely a 4. So it looks like a 4n squared. If I pull that out, I'm looking at 4n plus 7. All right. I have a common negative sign, and my binomial here has to have a positive, so I definitely want to pull out a minus. All right. This, if this is going to work, this 64n needs to become a 4n. So that's telling me that I need to pull out a 16. Oh, actually, I think it is going to work. Dang it. I must have been thinking of a different problem. Well, it's still a good problem because, check this out. You get your 4n plus 7. That common 4n plus 7. You'll see on my answer key online that I thought this was a different type of problem there. So I swapped these two guys, and it still works. It's cool to think about it that way also. Anyway, I have my common 4n plus 7, so I can factor that out. When I pull it out, I'm left with what?
4n squared minus 16.
Indeed. But that's not our final answer because what do we know about the 4n squared minus 16? We factored using what technique? Dots. All right. Or maybe I don't want to do dots. Maybe I want to use a different thing. I could also do a GCF. All right. So here's the deal. You look at this and you say, okay, well, which one is it? Is it dots or GCF? Well, the answer is it's both. If you do dots first, you'll have to do a GCF after that. If you do the GCF first, you'll have to do dots after that. So it doesn't matter which technique you use now, as long as you do the other technique afterwards. All right. I personally like to take the GCF out first, wherever possible, because in this case it makes things a little bit easier. If I take the GCF now, then it's definitely going to be easier because if I use the difference of two squares technique, I'm going to have two factors, each of which will have a greatest common factor. So if I don't do the GCF now one time, I'll have to do it twice later on. I don't want that. And it's not hard. It's just I don't want to do it. All right. So I'm going to settle on the GCF, and specifically the GCF is going to be equal to 4. So I'll put a 4 out in the front. And then we'll dot this bad boy up. All right, that's some serious factors there. You have 3 unique factors, variable related factors. Constant multiple is it's itself a factor, but it's not a it's nothing more than a trivial factor. It's not something that'll give you a solution if it were part of an equation. I think it was, let me look at it. I just want to look at number 13 real quick, because I think maybe that's the one I was thinking of. Let me just do it. I'll just do the first step. Or at least, I'll do it long enough to figure out whether it's the problem I'm thinking of. All right, well, what's the GCF on the left-hand side?
6x to the second.
6x to the second. All right, so that's giving us a 3x plus 7. All right, so again, in order for this to play out correctly, in factoring by grouping, so you can use this binomial to your advantage. Right? I know if this is going to work, that has to be part of the set of factors on the other side also. So that's what I need. All right, so then I can kind of work it backwards and say, well, what would my GCF have to be in order for 3x to become 36x? 12. Yeah, it's still not the problem I'm thinking of, but good enough. All right, I don't think you could ever get enough practice with factoring by grouping. All right, so now that you're at this step, and again, it's like, do you want to figure out the GCF, or do you want to let the factor itself tell you what the GCF is? All right, all you have to do then is verify that you're going to get that 84 when you multiply through with the 12. Because we know the 12 times 3x is going to give you the 36. That's how we got the 12 to begin with. But will the 12 by the 7 give you the 84? Yes, because 12 times 7 is 84. And so we're one small step away from our final answer. Just pull out that common 3x plus 7. You'll have 6x squared, well, 1.5 small steps away. All right, so at this point, you look at it and say, well, that's not a difference of 2 squares, so I don't think it's factorable, but I can do what? There is one thing I can do, GCF. And that GCF is what? 6. Pull out the 6. All right. So before I mentioned that the biggest challenge on a test is related to factoring by grouping. That has all the concepts built into it, but it all starts with the greatest common factor, the GCF. The most common error that students make on tests is the greatest common factor. Right after that is something like x squared plus 2, trying to factor that further. This one is completely done at this point, but the one thing that you have to kind of drill into your minds, and I've tried a bunch of different ways of doing this. I've even gone so far as giving questions on tests where I would say, all right, what is x plus 1 times x plus 1? All right, so this would be like question number 2 on the test. So choice C, for example, x squared plus 2x plus 1. All right, and then in question number 3, I'll say something like factor x squared plus 4. And choice D would be not possible. The reason I do it that way is to try to steer your mind into thinking about it the right way. And that's because this is not factorable. What people try to do is they try to take that x squared plus 4 and treat it kind of like a difference of 2 squares, except with a sum. You say, well, I'll just do the same thing. X and x, 2 and 2. Well, it's positive, so I'll just do a positive. But if I distribute this out, I have a problem here. I'm going to get x squared plus 4x plus 4. That 4x in the middle makes these two things not equal to one another. All right? But you can bet one of the choices on the test is going to be, choice C is going to be x plus 2, x plus 2. The good thing about multiple choice when it comes to factoring is that you don't really have to factor in order to get the right answer, right? You could go the other way. If you're in a jam, you're down, you know, like 10 minutes left in the class, you only have 2 questions left on the test, they both involve factoring, and you don't know how to do the factoring, okay. Well, narrow down your choices and start distributing them out. Don't factor, go the other way. Take the choice that you think it is and distribute it out and see if it gives you the thing that they're asking you to factor. All right, I think that's just the smart way to go about doing things. All right, but you got to start thinking that way because often, I actually had a class one year where all the students except for one for this question got it wrong, selected choice C. Like every student except for one. Like there was only one student who got that question right. And that was before I put this question before it. So, you know, try to guide the mind a little bit. But that's how common that mistake happens. And these weren't like a bunch of clowns in class. You know, they were hardworking students, did their homework, asked all the right questions, participated, got good grades. You know, there weren't a bunch of slugs in the class. They were doing the right thing, but they just couldn't get around that, right? So you got to work a little bit more to make sure that that trap is not something you fall into, right? It's not something, you know, that you enjoy, like the extra work, the extra practice, but it's definitely necessary, right? And I'm telling you that this topic, I mentioned in the beginning of the unit, is the beginning, not the end. Right, of your entire high school career and college, math, everything. So I have people in my Calc 3 class that still make that kind of factoring mistake. All right, so that's, so just kind of, you know, visualize that for a second. If you follow this path, so you're in Algebra 1 right now, if you don't take gap, if you just go geometry next year, Algebra 2, you'd finish with pre-calc. All right, start off in college, you would be halfway through your sophomore year of college before you got to Calc 3. So that's the age of student I'm talking about that's still making this kind of mistake. Why? Because I think they rush through it on this level. Right? So don't rush through it. It's very important. That's why I was doing those things with the quizzes. You know, like let's get better as a class average, get better than 75% or whatever it was, 70%. The purpose behind that was to slow you down a little bit. Right? You're not going to run out of time, right? Take it easy with this stuff because if you rush through it, you're not going to pick up that knowledge. And it's a learning experience you're never going to get back. All right. So, I also think about it like, so flash forward to senior year, and let's say that you never understood any of this factoring stuff. Senior year, you finally get it. And you're like, oh, I finally understand it. Now rewind your brain the last 4 years and think about all those moments where you could have gotten, instead of a 70 on a test, you could have got an 85 or a 90, all right? Just by taking that extra time now. You know, and I'm not just talking about one test, I'm talking about every test. All right, that's how important this concept is. It is never going away. It will be on every single thing that you do for the rest of your high school career. That's why we're not rushing through it. All right, very, very important. I can't emphasize it enough. All right, so anyway, end of speech. You're all sufficiently motivated.